you guys. I graded whatever stacks I had. They should have gotten back to you. If you have questions about that, about the grading or what have you, feel free to talk to me after class. If you didn't get your stack in to me by, say, I don't know, 8 o'clock Tuesday morning, I'll try to get to it sometime in the next day or two. 'Cause that's when I pulled them off of the submission queue. Today, I'd like to talk a little bit more about VI and handling more than one file in VI. You guys are commonly handling at least 3 files, 4 files at times, and there's no reason to have 5 windows open for each file, or to open a file and play around with it and then close it and open up the next file, play around with it, close it, and so forth. You can do all of this stuff from within VI. So I'll try to talk briefly about that, and then hopefully you'll get the idea and then read a little bit about how to do some of the finer details. Once I do that, I'll talk a little bit more about the program architecture, and then I tried to sketch out a plan of attack. This is a fairly complicated program you're working on right now. How do you get at this thing in baby steps? And it'll give you a way of not having to just kind of write the whole thing at once. What are some baby step approaches to getting this thing up and running? Okay, so first Vim. So for example, here's my stack setup. I've got main CPP, stack CPP, stack.h, and test.cpp, and then I've got this make file. I will often enter a directory and just do this. This is going to open Vim on all of the CPP files and all of the .h files. But when I open it, I just see one file, and at the top, or down here, it tells me it's main.cpp, and also up at the top here, it tells me that it's main.cpp in the header. Mac people, I don't know if you get the same behavior because it depends on the terminal program, but you might. It's possible. When you have more than one file open in Vim, I think I talked a little bit about this before. If you're in command mode and you hit the colon command, you can type ls, and you'll get a listing of all the files that are currently loaded in VI. And along the left-hand column, you see buffer numbers 1, 2, 3, and 4. The little %A, I don't know exactly all the symbols, but essentially it's an indication that that's the file that you're currently looking at, and you're on line 1 of that file. So if you're wondering, what files you have loaded, colon ls. Now, if you want to switch to a file, you can go to, say, file stack.cpp. It's buffer number 2, so I can hit B2, and I'll be in stack.cpp. And you notice the window title up here changed, and down here there's an indication that that's the file that I'm in. And now you see that the %A is moved down to stack.cpp, and then there's this #h, which means that the file has actually been loaded into Vim and you've looked at it. And these other guys down here you haven't looked at yet. So if I want to look at stack.h, I can do B4. And if you're bouncing back and forth, like I do this a lot, I'm bouncing back and forth between stack.cpp and main.cpp, or stack.cpp and stack.h. That's common to want to bounce back and forth between those files. VI will maintain will sort of keep an updated pair of files. So there's the file that you're currently in, and then B # will send you back to the last file that you're in. So if you're working, you can always go back to the previous file like that. If you have a lot of screen real estate and you're not using a massive font like I am, you can actually split the screen, SB. Let me get a listing here. So I'm currently in stack.cpp. Maybe I want to also see stack.h at the same time. sb stack.h. And now I've got two windows, two buffers open at the same time, and I can look at both of them. And I can switch back and forth just with Control W. That'll get me from one buffer to the other buffer. I've actually aliased that Control W to semicolon W because it's a little bit easier to type. And I don't remember if that's in your default vimrc that you got from me, but I'll talk more about that in a second. If you've done this and you're done with looking at, say, this file, you can hit close, and that'll get you back to the full screen. But even though you closed it, it's still there in the list of buffers. Okay. If you have a make file, Vim understands that, and you can just do make. Another nice thing is if there's an error, so you've got all of your files loaded, let me go put an error in one of the files. I'll go put an error in stack.h, so b4, oops, b4. Get rid of that guy. I'll go back to that other one, and I'll happily go make. And it says there's an error in stack.h, and I think it'll dump me into stack.h. Yes. In fact, it'll even find the error.
If you press, oh, is that when you press make from VI?
Yeah, if I do make in here, and this isn't exclamation make, which calls make from the command line. This is just make as part of VI. So it reports the error, and then it'll try to put you in the location of where the error is. And then I can put that back. And then everything is lovely again.
How do you go back to your files after make?
So whenever I run a command that is sort of complicated, like make, I think you're going to get this report at the bottom that says press enter or type a command to continue. I can either hit enter to go back to the buffer, or I can actually, you know, I can do make here, and I can type a command like b3. That's a lot to absorb. Try to just pick up one little piece at a time and add it to your repertoire, maybe week by week or something. Luke?
Is there a way to write all the buffers that are open at once?
Yeah, WQA. That writes all the buffers and quits. Oh, you could do WA also. That would not quit. But usually you're trying to get out. And here's something that also happens. Let me go.
Sure, if you just do WQ, it'll put out into one.
Yeah, that's what I want to show you. So let's say I go and I make a change to buffer 3. I'll just put a comment in here. And I haven't saved it. And now I'm back over here in buffer 1. And I try to quit. So it's telling me that I failed to do a write on test.cpp. Is that what it was? I don't know. Anyway, I failed to do a write on test.cpp. If you don't feel like trying to figure out where it is, just do a WQA. And that'll write everything, and then you don't have to go back and visit the file. But if you do, you can always just go back to that specific file, hit write. So it's going to protect you. It's going to let you know that you have unwritten changes if you have lots of buffers open, lots of files open. It gets even better than this, but I don't want to overload you at the moment. So there's a Unix system called ctags. Might be E tags here, I don't know. It might not even be installed. Anyway, I think it is installed. I think the people that wrote E tags and C tags might have finally given up and just moved it into Emacs and Vim rather than maintaining a separate package. But E tags and C tags lets you, like if you're looking at a function in your main program. So let's go here. You're looking at a function in your main program and you're wondering, where's the source for that function? If you have E tags up and running, you can just hit a keystroke command and it'll dump you into stack.cpp at that function definition so that you can muck around with it. Yeah, it's ridiculous how many features are built into this editor and the other editor, Emacs, for programmers. It's a programmer's editor. Any questions about that? Okay, let me show you. You may see me. You may see me when I'm running on simple programs. Let's see if I have a. There's one. So when I'm messing around with a simple program, you may have seen me compile it and run it from within VI. Let me talk briefly about that. A standard Unix trick. When I type ls, I see all the files in my directory. If I type ls-a, I get a lot more. And a really common to almost all Unix operating systems is the ls command will not show files or directories that start with a period. The reason for that is, by long tradition, Unix has kept configuration for different programs and so forth, in files and directories that start with a period. And 9 times out of 10, you don't want to see all of this garbage when you're just doing your day-to-day work. So ls usually suppresses that. If you want to see it, ls-a will say, show me everything. And there's lots of stuff in here, like my email aliases, my Dropbox stuff, configuration.
Is this the equivalent to like hidden files and all of this?
Yes, very much so. Yeah, there's just all kinds of stuff in here. Most of this stuff I didn't put here. Most of the stuff was put here by the programs themselves. And if you do an ls-a on your own directories, you'll see lots of the same kind of stuff. Okay, the one that I want to point out is this vimrc file. And you can see I talked a little bit about this earlier in the day. Let me undo some of the damage, and then I'll talk a little bit more about this. So in my .vimrc, which has all of the startup configuration for VI, I've got just lots and lots and lots of settings for VI. 2 settings that might be of interest to you, among others, are the ;G setting, which writes the file and then compiles it, and the ;R command, which then executes the resulting a.out file. This is what I do when I'm doing quick examples in class. I hit semicolon and then a G, and it compiles, and then semicolon and an R, and it runs. It's pretty handy. And for you guys, you're going to be using make more than you're going to be using these 2 guys. But if you want to muck around with my vimrc, what I suggest you do is move the old vimrc out of the way. I typically move stuff out of the way and put a little date stamp on there just to remind myself when I actually did all this stuff. So I use the move command, mv, that takes my current vimrc and moves it to a new file name. And then I've placed a copy of sort of a plain vanilla vimrc on my web page. It's actually in the 167 directory. And you can retrieve that file from my website and have it just land right in the right place with this command wget. Wget is just a command line file HTTP transfer program, and it'll go to my website, request that file, and then save it in the local directory. It happens really quickly because it's such a tiny file. It's only 9,000 bytes. So it downloads really quickly and then saves it into that directory. Once you do this, among other things, you'll have the ;R and ;G command. Any questions about that? That's a lot to absorb, I know, in 15 minutes.
I guess how much toying could you do with the vimrc before things start to go whack?
Well, I mean, there's the documentation, and God knows I've had lots of trial and error experiences with vimrc. You make small changes. If they break, you just undo them.
But pretty much everything is like customizable, if you will.
Almost, yeah.
Okay.
In fact, I was struggling with, well, I'm not going to go into it, but it's an ongoing process. I've been using this editor since 93, 94, and just recently ran into an issue, and it took me, a couple of days and a couple of posts to the Comp Editors news group to resolve a problem. And I feel like a weight has been lifted from my shoulders now that I've resolved the problem. It makes me very happy. All right, that's enough about Vim for now. I encourage you to really engage this program. It can do nearly anything that an editor, that a programmer wants from an editor. All right, last time we talked about the infix expression parser and some of the big ideas about tokenizing, and then the operator, dealing with operators and what have you. What I want to do today is show you a little more in detail how I implemented my version of the program, and then I will talk to you about what are some things that you can go home and do today to get moving on this program, because you really do want to start it now. So let me show you mine. And I guess the place to start is main. So I have two classes that I'm using, a get token class and an operator class. And let me start with main, and I'll show you how I'm using them. So my expression parser is driven by this loop. And the loop just runs, it's just while one. Okay, so it's just going to run indefinitely until I break it. I'm going to prompt the user for an expression, and I'm going to check to see if the user just entered nothing. If they entered nothing, then the loop's over, and the program ends. Otherwise, I'm going to get ready for a new calculation. So I reset my tokenizer, and I reset my object. And then I drop into this next loop. And this next loop is parsing tokens, taking tokens off of the input stream and pushing them onto stacks or executing them as the case may be. So let's talk about this inner loop. So this inner loop, again, is expressly for the purpose of parsing a single infix expression. This inner loop will end when I get to the end of the expression. So when the end of stream function is true, I break and I'm out of that inner loop. My tokenizer goes out and gets the next token. And one of the things it does is it identifies the type of the most recent token. If the type is N, my shorthand for number, I'm just going to push that number, whatever that number was, onto the num stack. So my tokenizer is responsible for two things. It's responsible for identifying what the type is of the token. Is it a number or is it an operator? And then actually getting that operator or getting that number from the input stream. If it's a number, then numbers are easy. Push it onto the num stack. Here's where it gets complicated. If it's an operator, so this character O is my shorthand for operator, what do? Well, now we use the ops object to compare the recently read operator to the operator that's on top of the op stack. And what do you think compare is doing?
Return the variable if the read-in returns true if the read-in has higher precedence.
Yeah, compare is consulting the precedence table. If it's true, push it and walk away. If it's false, now we're into the else part. So far, not too bad. Pushing numbers, pushing operators with high precedence. Of course, we're obviously going to run into times when we get low precedence operators. In that case, I drop into a while loop. Talk to me about that while loop condition. While not ops compare, what am I doing there? What's that while loop doing?
Well, the operation that's coming in has a lower priority? Higher priority? Higher priority. Then it evaluates all of the previous operations.
Yeah, so it's going to pop operators off of the top until you get a push. Until you get until it's higher precedence, right? Okay. That may run the stack completely dry. In which case you're going to be at an empty stack, and then you're always going to push it onto an empty stack. So ultimately, this while loop will stop. It'll either run the op stack dry, or it'll get to a lower precedence operator, and then you can push it. Either way, this while loop will terminate.
So your token.type just returns a character depending on...
Yeah, and I wrote this program years ago, and there are definitely things I would do a little differently. For example, I frown upon the use of bare characters like that. A better thing would be to use, I'll talk a little bit about it, but a better thing would be to use a named constant there. Something like
number.
If token type equals number, big capital NUMBER, and use a define to define that, would be a much better way than
So
this.
then you just have like 0 through 3 to be n.
Okay. Let's keep going here. So we run this thing until we get a lower precedence operator on the top of the op stack, and then we evaluate. There are a couple of weird cases. Oh, ops eval op. So ops eval op goes to the operator stack, and it takes the operator stack and the number stack, looks at the top operator, and evaluates it. And if it's a binary operator, it pops 2 numbers off of the num stack, does the operation, takes the result, pushes it back onto the num stack.
The way that we wrote our top in our stack, we use the assert thing, and would that cause a problem here when you try and do op stack top if it were empty? What would happen with that?
Right. I can't remember what I did. Let me think about it for a second. Oh, I remember what I did. Remember I was talking about, if you read David's book, he has this virtual operator with ultimate low precedence. Does that ring a bell at all? Okay. I used that. And so I never had an empty stack. I just had a dollar sitting down there, a dollar sign sitting down there with ultimate low precedence. And so you're guaranteed, when you get down to the dollar, which is the first thing on the stack, you're guaranteed to push.
So what happens when you, I don't know, I guess that would just be a trick of the code, but I mean, because technically that'll have a lower precedence than other things, and so then wouldn't it, would it eventually get evaluated? Or do you just have it not as part of the evaluation?
Right. That's the way I know that I'm done.
Yeah.
I guess is
Okay.
when I have the dollar down there, that I know I'm done evaluating.
And then at that point, if you have more than one number on a stack,
Then there's an error. Yes. Okay. If the most recently read is an RPN, then pop the stack. What's going on there?
Right parentheses.
When I get to this point in the code, either I've emptied the stack or there's a left parenthesis. Sorry, if I've read an RPN and I get to this point, there's got to be a left parenthesis sitting there. And so RPN, this is the way the RPN annihilates the LPN, is if I have an RPN and I've run the thing to, right, I have an RPN in hand. So this thing right here, this thing is an RPN. The RPN, the only thing with lower precedence than an RPN is an LPN. Or the bottom of the stack. If it's the bottom of the stack, there's an error, right? Because you have mismatched parentheses. So the only thing with lower precedence than an RPN is an LPN, but you don't want to push an RPN, right? You just want to get rid of the LPN that it's associated with. So you do that. Otherwise, push the operator. You've reached a lower precedence operator, push the one that you have and move on.
How does pop know to pop the left parenthesis as opposed to just the operator in between the two left and right parentheses?
Well, I ran this loop. So again, pretend we have an RPN sitting here.
Okay. Yeah. Because you'll evaluate what's inside first, and then okay.
And so it's just going to drain that stack, and the only way it's going to stop is if it gets to the bottom of the stack, which is bad, or it gets to an LPN. If you have an RPN. Now you've got an RPN in hand and an LPN on stack. What do? Throw this away, and move on. I've got some error trapping in there, but probably not enough. Feel free to put more in if you are so inclined. Let me show you my operator header. So the operator class is responsible for all things operator. The op codes are in here, and the recipes for evaluating the operators are in here. Right? What's a recipe for evaluating addition? Pop two numbers, add them together, throw them back on the num stack. What's a recipe for unary minus? Pop one number, change its sign, and put it back. How do you change the sign? You can use the built-in unary minus, right? How do you add two numbers in C++? You use the built-in addition operator, right? So,
you don't want to overload them so that they do the same
yeah.
thing.
So, and it's the same. That's why it's really easy to add operations to this thing, because you just can use the existing C++ operations. You know, it's easy to add cosine. How do you do cosine? You just use the CMath cosine. If you had to roll your own cosine, that would be something else, right? Something worth thinking about, but we'll talk about rolling our own cosines later. So my opcodes are all preprocessor defines. So I define error to be -1, add to be 0, sub to be 1. These are all completely arbitrary. And really the thing that matters is that they are consistent with the array that holds the precedence values. That the numbers that you give to each operator correspond to the index in the precedence array for that operator. I tried to use all three-letter constants because it makes my precedence table look nice. Your precedence table doesn't have to look like this, but I'll show you mine. All right. My precedence table uses something that I don't know that we talked a whole lot about in intro C++, but you can fill in an array at declaration time using this syntax. If it were a one-dimensional array, I could declare this one-dimensional array and I could make this row, I could make the values in the array equal to this row. So this is the 0 index, the 1 index, the 2 index, etc. If it's a two-dimensional array, what I want is an array of arrays in this syntax. So I have an open curly brace. This is saying, okay, I'm starting an array of arrays. Each element in this array is an array. There's the first element, there's the second element, the third element, and so forth. Each row, the row number corresponds to this slot, this index, and the column number corresponds to this slot in my picture. This is a clever use of comment syntax to really indicate to me what I'm doing. So here's the incoming operator on the left-hand side, and across the top is the operator that's on top of the stack. 0 is false and 1 is true. And I have, say, a subtraction operator in my hand, and I want to know whether I should push it onto multiplication. I go to the subtraction row, the multiplication column, and I see false there, so I don't push it. I have to evaluate that. I see my LPN, my left parenthesis. That guy goes on top of everything except an RPN, which really that shouldn't happen anyway. RPN never goes on top of anything except an LPN, and in that case, or the bottom of the stack. That's my DLR, my dollar, my virtual operator, and that's that statement that we discussed earlier. I have an RPN in hand and I pop the stack until I get to an LPN. That makes it true, and then what do? I just get rid of both of them. Okay, if I want to add an operator to my list of operators, I simply define a constant over here. The next one would be 10. And then I'll go over here and I'll add a 10th row and a 10th column, and I'll fill in the 0s and 1s for the correct precedence, and then I'll move on. Questions about that? Somewhere in your program, almost certainly you have to have an array like this. And you're going to be consulting it. Every time you get an operator, you're going to be consulting this array about whether to push it or whether to evaluate it.
Why do you have static and constant there? What's the difference between the two?
Where?
Static and constant.
Yeah. That was just me being silly too. If you do a static variable in a class, all of the objects in the class will share the same memory location for that variable.
Oh, so they'll just all point to that.
So if let's say I have a class and there's a static int in there, n, and then I declare 600 objects in that class. If I change n in any one of those objects, it'll be changed in all of the objects because they share the same memory location. It's a way of getting objects to communicate with each other, sort of a backdoor way of getting them to communicate with each other. So If I make a change to one of these static variables, suddenly every other object in the program is going to know about that because they all share that same memory location. I don't need to do it here. There's only one operator object in the whole program. The reason I even thought about it was if there were more than one, I would want to save space. I don't need precedence tables. The precedence tables are going to be the same always. And if I had more than one operator object going, there's no reason to make copies of this table everywhere, just one copy.
Because you do the same thing with structures.
I don't know. That's a good, probably, yeah, because I think the static keyword will work in there as well. With me so far? Okay. I think Luke was in my office yesterday, and we were fiddling around with this thing, and asked what would happen if I did this. And my program will crash. As opposed to if I do this, say -2 + 2, where it works. What's the difference between this plus sign right here and this plus sign right here?
One's unary and one's button.
Yeah, it's exactly the same as the unary minus issue. It's a unary plus. The reason I didn't implement a unary plus is just because there's not a whole lot of reason to do so, but lots of parsers will accept a unary plus. If you want to implement a unary plus, it's not that much different than a unary minus. You just have an extra flag for unary plus, and you're going to set
nothing.
Well, it doesn't do anything except prevent syntax errors.
Yeah.
For people that like to put plus signs on things. Okay. Let's talk about the stacks. There are two stacks that you're going to use, the op stack and the num stack. In the last 24 to 48, I've kind of weakened a little bit. If you want to just use the STL stack, I'm fine with that. If you want to use your own stack, that's also fine. If you use the STL stack, you have to include the stack header up here. And stacks in the STL stacks are what are called templates. So you have to actually say what kind of data type the stack is going to hold. So here, my op stack is a bunch of integer codes. The syntax for saying that this stack will hold integers is stack less than int greater than op stack. And that defines this thing to be an integer, a stack of integers. And similarly doubles. And you can put any data type in there that you like.
Could R above and beyond be implementing that header in the stack? I know it's
Implementing template? Yeah, if you want to, that would be great. Yeah, templates are definitely useful things to know. It lets you write one class that can handle lots of different data types.
Sidetrack. Can you do that if you have like 2 data types in the class? I could just think about that.
Yes.
Are you saying yes, you can?
Yeah.
Okay. What is it? Comma separated list?
Yeah.
Okay. Makes sense. I've never done it with 2.
You can also give it constants, which is just insane. You can go int comma 10 and give it a max, like length of 10 on the stack. That's crazy.
Okay. It makes sense, but like I said, I've never done it, so I'm not familiar with the syntax. But yeah, why limit yourself to one data type, right? So feel free to use the STL stack if you'd like. I declare these 2 stacks outside of both of these important classes because getToken needs to wrestle with both the op and the num stack, and operators needs to wrestle with both the op and the num stack, right? Get token is going to get a number and push it onto the num stack. Get token is also going to get operators and push them onto the operator stack. Operators is going to evaluate operators. If you're going to evaluate an operator, you need to get the top operator off of the op stack, and you need to get a couple of numbers off of the num stack. So you need access to both of those things. So there's not really a way of, there's not, I think, an elegant way of hiding these stacks inside the classes. Okay, let's talk about, in the remaining few minutes here, some baby steps towards writing this program. Okay, here's stuff that came to my mind. We can talk about possible different approaches, but I think it'd be good to somehow write a parser. So parse the incoming expression. What do I mean by that? I mean by eat spaces, report numbers, identify operators, and identify the end of the expression. So a good starting place would be a simple program that prompts the user for an expression. And then your parser comes along and just prints out debugging information. It says number 2, operator plus number 2, and just goes through the list and then it prints out end of expression. So if you can write a program that will go through the incoming thing and identify operators and numbers, you're off to a good start. This is not in any way going to be in your final product, in the thing that you turn into me, but these programs are getting too complicated now. That's not how you write programs anymore. Maybe that worked in first semester, but it doesn't work that way anymore. If you try to write this all at once, it's going to be a debugging disaster. So start out, write a simple function that can parse that incoming thing and just simply print to the screen for no one's edification but yours. Number 4, operator, parenthesis, number, and just prints out this simple debugging information that proves to you that it's parsing the command line or parsing the expression correctly. Put in extra spaces, right? See if it handles that, ignores the spaces. I guess then the next baby step would be to distinguish between the unary minus and subtraction. So you've written this parser in part 1 that all it does is go through the infix expression and print out what it's encountering. Sometimes it's going to encounter a minus sign, right? And what you want to do is get it to tell you whether it's a unary minus or a subtraction operator. This might involve you writing the beginnings of a class if you decide to write a tokenizing class. Or you don't have to use objects at all. All of this can be done with functions that are declared above main and written below main. So none of these have to be classes. I did it with classes because when I wrote this program, I was learning C++, and I just wanted to do it with classes. But it's by no means is it necessary to do it with classes. So there's the next baby step. A third baby step would be to convert the encountered ops to their opcodes. So hidden inside that baby step is you've got to do all the defines, all the constant defines at the top, and then you've got to, if you have a parenthesis in your hand, how do you a left parenthesis? How do you turn that into the corresponding opcode? Some kind of switch statement or if statement or something takes that parenthesis character and converts it to the appropriate opcode. But you're still just kind of running this baby parser. And now the parser says number 4, operator plus character, and then the opcode 0. Number 5, operator multiplication, MLT or something like, you know, and it just distinguishes, it lays all that stuff out so that you see that it's doing the correct thing. Okay. Now let's work on the operator side of things. Populate a num stack and an op stack with a known expression. For example, 2 plus 3 minus 1 times 2. Right? You know how to populate the num stack with that thing. Sorry, the op stack and the num stack. See if you can do that, and then see if you can run off operations. See if you can do the top op. In fact, maybe you don't even want to get that complicated yet. Maybe you just want to do 2 plus 3. So there's 2 on the num stack and a 3 on the num stack, and there's a plus operator on the op stack. See if you can execute that.
Does the way we're currently writing this, it doesn't ever get the full expression on the stack.
Right.
Like, will it work if you do get the entire expression on the stack? Like,
no.
Yeah, that's what I thought.
And that's why I backed off with this thing. Let me think about, because what that plus sign is going to do is it's going to run off, well, that right parenthesis is going to run off the minus sign, for example. So yeah, keep it simple. You can build up, though. Give me something that gets 2 operators on the stack. You think of one that gets 2 operators on the stack.
2 plus 3 times 6. Yeah, we'll just second the 6 before it evaluates the times.
So that one would be a good one to test. And yeah, you just what's the deepest? Can you make it arbitrarily deep?
With parentheses. Right.
No, because aren't ties evaluated?
Well, that's the question.
You can only do it with parentheses, I think.
Yeah, like 2 plus 2 plus 2 plus 2 plus 2 plus 2 doesn't make a deep stack, right? But can I make a deep stack? Yeah, I can use parentheses to make a deep stack. Or if I have something that's evaluated right to left, I can make a deep stack, like exponentiation or something. But that's worth thinking about, right? How do I get a deep stack? Okay, so populate a num stack and an op stack and see if you can write a function that will evaluate the top operator and then push the right thing back on. So do 2 plus 3, do 2 times 3, do 2 minus 3, do 2 divided by 3. Okay, I'll leave you with, build the precedence table. Get rid of that example. Build precedence table. And remember that opcodes correspond to array indices. That's the really important thing about the operator codes, is that they correspond to the array indices in the precedence table. Build a precedence table, and then at this point I think you're ready to tie it together. But for example, item 1 is something that you could go home and do right now. And it will get you on the path to writing this full program. This is how large projects work. You have to build a path of small steps, small debuggable, manageable steps towards the end goal. All right, any questions before I turn you loose?
When is this due?
Go ahead. It's due Wednesday, a week from today.
When we're eating white space,
Yes.
do you want to just ignore the white space? In the instructions also like spaces delimit numbers.
Just do something like this. While cin.peak.
I guess my question is, if there's like a 2 and then there's a space and there's a 9, is that a syntax error because there was
Yes.
no operator between, or should we just ignore the space and make it?
That's a syntax error, and if you get 2 numbers in a row like that, you just say there's a syntax error.
So we wouldn't read. So if it was just 2-9, we wouldn't read that as 29.
If it's 2 no space 9,
Okay.
read it as 29. If it's 2 space 9, you're going to get that 2 in. It's going to be a number, and maybe set a flag like the last thing I read was a number. Then I eat the space goes away, and I read the 9, and then I've got an error trap in my program that says if I have a number and the last thing I read was a number, I'm done. But those are niceties for at the end. While cin peak is not equal to enter, just do cin get. And that's a quick way to eat spaces. All right. See you guys Friday.